Okay, so the tool vise was looked at from the standpoint of moving this over to a CNC manufacturing strategy, as opposed to the castings and then finished machining. Some of the tolerance, even on the casting or the cold rolled steel, um, still required quite a bit of machining. We'll look at the weight and the overall after we get a little further into this. So let's see, lower plate. Nope, that was the get my drawing back up here. All right, so number one. Oh, yeah, it was in sequence, and I went right to the. Okay, so into the assembly. I'm going to bring in the saddle, and its position can go to the fixed position. And okay, so I'm going to be 90 degrees out from the isometric that was in the view. I don't care. Right? It comes back to if it's pointed this way as opposed to this way, we'll rotate it to that position and put it into the drawing or the assembly, or from the assembly drawing, drag the isometric to the left instead of the right. It's not a big deal. All right, but I want to make that that conscious choice up front. So again, from the CNC manufacturing, I eliminated the upper boss. We'll have a hardened washer or something to seat to. The radius is over the top and on the inside. If I was going to do anything here with a radius, I might use a hog nose or an end mill with a nose radius on it, so that it would put just a little bit of relief. But I'm not looking at this from a lot of load for whatever it is that we're grinding, holding on to. I don't see this as a potential stress riser or critical stress riser, so I'm going to bypass that. All right, so next piece is going to be the center. So let's get back over to the assembly, insert the components, bring in the center compound member, place it, and because I did these on the origin, I do have the option of aligning plane to plane. So from the center plane, I can look front plane of the part to the front plane of the assembly, go into its mate, and that should put us on center line. Now there was also some extra relief and some extra geometry in here that I want to check for. So let's go arc to arc, and those will be concentric. And I do want this to be able to rotate, but not just yet. So in that case, I'm going to find the right plane. And one of my strategies, again, is instead of going directly to coincident, if I use parallel, parallel is easy to identify. All right, so if I make that parallel, that would be something that when I switch over to my dynamic, I want to see what the range of motion is. I want to put limit dimensions in as I start to set up from the default, everything being static in its kind of fixed position or in its position, to moving over to a dynamic assembly. It's going to be those parallels that I can look for instead of having to search through however many coincidences. All right. So if I did this right, I should see just a very few nominal distance 3/1000ths. Hopefully that is in instead of out. Kind of hard to tell until we zoom up. So I have just a little bit of relief there. That seems like a reasonable clearance. When we get over to the evaluate and start looking for some of those clearances, I want to kind of physically measure, but cross it off my checklist before I get to the interferences. All right, so that gives me the first position. We'll go ahead with the upper. Okay, so that one still has the sketch marks. That's making it a little complicated, so let's go ahead and hide those. And I haven't set up any display state, so when I hide out of the assembly, that's going to be hidden in the part. I can set up a display state that says show those tick marks, those angular marks, if I want to see them, but I can't really get rid of the center lines and the other construction geometry until I get to that point. All right, so in this case, we want this to be able to rotate, and this is going to be able to move back and forth as well. So my first guess, my first impression would be to go back to the assembly, but then I start to analyze it and say that that's not a good idea. All right, this piece has, or these two pieces are going to move together. So if I make this coincident with the front plane, then it's going to stay in that up and down position. It's not going to be able to rotate back and forth. So in that case, I want to look for a comparable plane in the center so that as it moves back and forth, that's still not going to do it. Wrong one. Okay, so that one, the right plane. I keep guessing at it. Eventually, I'm going to find one of them that works. All right, so right plane of the center to the front plane of the upper. That looks like it would be reasonable. It's going to be able to stay in position, and because I'm at that angle, it's moving a little bit weird. I'll go ahead and set for concentric, and now I expect it to act in that same arc. All right, so as I'm going through and doing the analysis, I'm not always going to guess right. All right, but I'm going to kind of keep a mental tab, a checklist of, yeah, that seemed like a good idea at the time. If I need to go back and pick something up, then that's going to be where I'm going to start to look, is the relations between these two parts. All right, so that same in that same vein, the front plane of the center, and we'll scroll down to should be the right plane or back to parallel. So again, I'm looking for that very static. I don't want anything moving. I'm more concerned with the clearances, finding any interferences in the stack up. I want to be able to identify those. So let's go ahead and save this. And this is going to be the tool vise, and we'll go ahead and put a 1 on it so that I can do this again. All right, so let's refer back to our assembly. We have the two plates on the bottom, and then the relief one with the relief on the top. So let's go ahead and put that in place, and we'll start to define where those hole locations are. All right, so let's see, item 4. I guess I need to figure out which ones those are. So items 5 and 6, 8, 10 for the plug. Oh, and the tool holder was up top. Yeah, we'll go ahead and bring that one in. All right, so it's going to sit in position, coincident, back to the bases. Cylinder is probably my best choice there. Oh, didn't hold down the control button, so let's get that in position. All right, so all the little blue dots for the origins are starting to annoy me, so they're getting ready to get turned off. As far as position, I know that the protractor scale overruns past center, so that's about its position. And staying with that stack up, if I run into it, we'll go with the right plane of the holder and the right plane, and again another parallel. Okay, so those are all of my major components. Go back in and hide the origins so that kind of cleans up. And we'll see if we have the clearance. That one's about 4 thousandths. That one was about 3 thousandths. So we're still in that same range, even though it's A little on the weird side. All right. Next piece is item 5, insert component. And you can tell that I'm falling into my my old habits of insert. The toolbar. I have a long standing on the pull down, so whichever one works. All right. So control coincident. We're going to look for that hole location. And I thought these were a little bit on the large side, but it's relying on the pin. So I want to check for alignment by going concentric to concentric, and then the hole location for the handle. All right, so completely missed on that one. Let's go ahead and bring in the other side, the 2 lowers. Oh, that was an upper, so that didn't work. I don't use it often. I probably would have just either undo or deleted the relations and moved this over. There is in our pull down a replace components. All right, so if I browse to the lower plate, I'm going to try to replace the component. All right, so it's going to match. It's going to reattach mates if it can identify. So the face was identified. The concentrices were identified, so that's all good. We go ahead and accept it. All right, so the difference was this lower one doesn't have the relief for whatever screw goes through there. All right, so keep in mind that you have that ability to replace. All right, so that one goes in. Control select coincident. All right, but in this case, the alignment wasn't there. It put it inside of the part. So I didn't go into the full mate. I want to expand out, look for the mates folder, and then flip the mate alignment. All right, and then same thing, I want to check for those hole locations. So we're going to set for concentric, and really the 1/8 inch holes are a lot more critical than what I'm doing for the counterbore holes. But I need that initial position even to get them started. So, all right, so I have that first piece of information that I can build in. All right, so we're going to chase that one back. All right, so insert components. We'll do the upper plate. I haven't set any mate relations for these items, for these components. Mate relations fall into the category of if we're reusing this part across a variety of tools, and maybe it even goes into the to the design table or the design library at some point, then the mate relations become a little more critical. Okay, so concentrices. All right, one more upper. And should have just done it the opposite way, then I wouldn't have had to flip the mate alignments. All right, but good example, flip mate alignment, put it in position. Got a concentricity, we'll rotate that up just a little bit. Rotate it up. All right. So we're starting to cross off components in our list. We're getting down to the last few. All right, so that goes that way, that goes that way. On the center compound, oh, that was, did that one get it? If it did, I did not catch it. All right, so pretty much the tick marks in the 0 through 15 that I put on this one, I'm going to have to grab that sketch and copy it over because it's going to have the same tick marks. All right, so the alignment to this point for our reference, 15 degrees off of center. So let's see, we're going to check it for this one then. All right, I really just need one of them turned on, and actually I don't even need the numbers. Go ahead and show. All right, so just a little bit off on that that alignment. We want it to be pretty close. So if that's our 0 mark, I need about another degree, a little over a degree, to make that alignment. All right, so or I need to check this and pull it back, whatever that that angle was. All right, so that being our reference, that's just a little bit off. All right, fasteners, not yet. We still have a few more components to bring in. All right, so we got the upper, we got the lower. Locking handle, probably not. Need to build up a little bit more the eccentric. And actually, without the exploded view, I'm not sure where the eccentric should end up. Let's see what that call out was. Drill with P7. All right, so that ties in. Oh, they're actually going to put that in bind. It's not a compression. Okay, so I'm going to set that one up for the mate. So that goes in first. And that really can't stick out, so it's going to have to be flushed. That's an interesting way to do that. All right, so since I have to do 4 of those, well, 3 more anyway, and I've identified what the mate reference can be, I'm going to go ahead and put one in. So this edge, reference geometry, mate reference, edge default mate any, and go back and save. All right, so when I drag the next one in, I want to be kind of close to the hole location. It's reversed, so I got to do the contortionist thing on the fingers and hit the tab button at the same time. That'll put that one in position. One more to there, tab. And tab. Now back to that whole design for manufacturing thing, based on the cost of that eccentric versus drilling and tapping a hole, and the cost of a handle versus the locking handle, kind of the specialty custom items, I'm really leaning towards, since that was where did it go? They had 265. I'm really leaning towards maybe a quarter 20 or a quarter 28 to replace that with a standard handle. I don't know, that seems like it would be an expensive piece that we could replace and bring the cost and have the same efficiency. A washer up against this, I think these were cold rolled steel. Washer against that face, providing that compression. 3/1000ths of clearance, whichever one pulls up tight. Yeah, I know that there was an upper and lower limit on those. So whichever one gets tight and flushed, then the stack up kind of shifts into in that direction. All right, so that's a candidate, and this may be where we could go back to the design binder. Depends I've used the design binder to take notes as we go, but it's probably as easy to have Word open in the background, or just take and scribble notes somewhere. All right, so we're pretty good there. So I'm going to leave those open. Item 7 can come in now. So insert components. Bring in the locking handle. All right, so the locking handle has the relief for clearance. We'll go back to concentricity. Another candidate for the mate reference, and it's moving away from me. So let's bring that one back. That was just trying to be annoying. And that was just a little bit of there we go, just a little bit of spot face for it to engage into. So I think we could probably purchase a handle for the cost of making this two-piece assembly. And it would probably be much more cost effective finding something that's already close. All right. They do look like fun to make, but yeah, not that much fun. All right, so concentric. Those are all going pretty good in the same directions. All right, the other thing would be the handles. So what was the note on that one? Let's see, drill with piece 8 in assembly. So I think the issue here is that, well, as long as it will turn. Nope, it contacts. All right, so if we get this too far out of alignment on the eccentric, or even on the threaded holes, we're not going to really be able to clock threads to the stage. So this handle is going to have some adjustment to it. So that's kind of unresolved issue to be determined. All right, so one more, and we'll bring that in. Go concentric. All right, so that has a good amount of clearance. So based on that much clearance, I'm not sure why we need a that heavy step. We could probably get away with just making that profile, putting a nice deburr on it, and calling it good for the lever. All right, so we'll put those in some position that I'm not going to worry about making all of those parallel. And mainly the reason that those the 3 center sections went parallel is because as you start moving these things and it sees that this can move, you're going to have that accumulation of movement. All right, so let's see, what did insert components, item 8, so we're up to the protractor scale. So let's see how that turned out. All right, so the sheet metal piece wrapping around the body. Gonna set concentric and lost it in the part there a little ways. Really would like to hit the bottom there. So one of the things, when was it, 2015, 2016, if you hover over top of a part and hit tab in the assembly, it goes away. And that wasn't really the one that I wanted to go away, so shift tab brings it back. Tab makes that one go away. All right, so we're pretty much going to pick whichever cylinder. So those can be coincident. And depending on how this generated, nope, it's still going for tangent. That means that when the sheet metal wrapped that cylinder around, there's still some kind of compound curvature into that that whole location. So back to our planes. So there's a front plane that would work, and we're going to go back up to that the tool holder. Front plane, no. Right plane, yes. Coincident. All right. What I was saying about the positional tolerance, that 440, 112 going to 136. The 136 hole really could probably be dropped back to a 120, 122, 125 at most. I don't think it needs that much positional to be tight. And chances are to make this thing stick, going to put a little bit of glue on the backside or some kind of attachment through the whole face, and those will just keep it in position. All right, so go back and show. All right, we're getting down to the last of the pieces. So interior, and this one's going to be a little bit interesting. So insert component, we brought in the protractor scale, so that leaves the plug. All right, so this plug goes into the through, and I lost it. So let's go into our move components. So by selecting it out of the feature tree and from move components, I can extract it. All right, it is going the wrong direction though, so we're going to flip the mate alignment, put it in position. Should be able to hide that. Find that curved surface back to that planar surface, and those can be tangent, maybe, or not. Okay, so did it pick up tangency and did it locate correctly? All right, so it's got the angle. That looks pretty good. All right, so find an open spot, Shift tab, brings that back. We'll go to the clamp plug, set the mate. So let's go ahead and flip the mate alignment. And if I can see it in there, which I think that's it, and can control select, I can get back to tangency, and we just need to double check that it went in correctly. Okay, so those are the angles. It's going to do the pull down, and we can do the shift tab. All right, so far so good. Make sure to save. All right, so what is left on the clamp plug? We got tangency, but it's still under defined, so that's going to be one of those weird ones that it really doesn't move, it doesn't change position, but it's probably because of the combination of the tangency and the concentricity, it's not going to go fully defined, and I'm not going to chase it. Okay. So the test, we go back to the upper compound member. One of the tests will be to identify that parallel and suppress it. And if that that plug doesn't come shooting out on one of these. So let's see, I would like to go transparency. All right, so that's looking pretty good. Yep, got to rebuild. So I didn't like something when I started moving that. Alright, so there was the mates. That's going to keep, nope, that one's okay. Suppress. Nope, didn't get it. Oh, that was the upper. Okay, so unsuppress. Okay, time to set the configuration for the dynamics, so I don't have to chase these chase the parallels too far. All right, so let's go ahead and suppress that one. Now it's not giving me the fixed, but it's not moving either. So I didn't think there was that much of a stack up of parallels. Compound, center, let's go one more. Now that one needs to be okay, so that positions back to front. Okay, so maybe I should have been checking those along the way. So one of those came in. All right. Well, I go ahead and unsuppress those. So I'm not sure what I added, but we're not there yet. All right. So dynamic will be the next challenge. All right. So I'm going to jump over to the toolbox so that we can finish out the hardware. And our hardware list for 3/8/16s and hex. So put that back in transparency. All right, so quickest way, we're going to go back into the design library. If I select the toolbox, we can do the add-in now, which is the same as coming over to the SOLIDWORKS toolbox, which is the same as the pull-down for the add-ins and telling it to add the toolbox library. The toolbox utilities are the life expectancy for bearings, the O-ring, well, grooves, internal, external, and O-rings, and beam calculations, those types of things. So we don't need those turned on just yet, but they are there. All right, so under the design library, let's see, did I add anything to the favorites that's usable? Nope, couple socket heads, button heads, no set screws as of yet. All right, so back to ANSI inch. Bolts and screws, I'm looking right at it. There we go. Set screws, they're going to use the socket, so we're going to stay with socket. And we want a cut point. All right, so one there. It's going to come up and ask me 3/8/16 is correct, and the length is 1.5 inch. And that is not the correct direction, so we'll leave that one for now. Place the next one, hit tab. All right, make sure the sockets are going the correct direction. And can't say why these need to be 1.5. Either that or put them in the wrong spot. Well, I guess if they have to go almost all the way to center, they could need to be 1.5. Just didn't pick that up on the drawing though. Yeah, I guess. All right, I'm buying that. All right, so we do need to come up with a reasonable position for it. All right, so no distance. Probably not going to find one on the cup, so that leaves the outside. Half an inch looks fine. I'm not so concerned with rotation. But again, when we start the dynamic, I really don't want these jumping out, getting lost, doing strange things. So I'm going to go kind of through that checklist of will this retain most of the motion, and again, if I needed, I can always go back and tell it to lock the rotation. First item was backwards, so we're going to flip the mate rotation, and there was the lock rotation if you don't want it to spin. So pull that. Oh, wrong one. There we go. Set up for the mate, distance 0.5, and one more. Yep, that one stayed a little bit big. Nope, that was the second one, wasn't it? Okay, then we'll take the quick route. All right, next one is a 9/16. So that's kind of an oddball size. It either jump up to 5/8 or ½ inch. Cost-wise, probably not looking at all that much, but still, it's kind of we're at that point of making the decisions. So 3/8/16, I'm going to bump that up to 5/8. Rotate around. That looks good. All right, for its position, since we started there, go to the back of that plug. That'll be coincident. All right, we've got plenty of clearance there, so I'm not sure why. I don't think it needs to be flush anyway. Ran into clearance issues. Would probably go down to the ½ inch before I pick the 9/16. All right, somewhere along the way we're going to do another save, and starting to accumulate hardware. So this is a good time to set the folder. So Control select all of those or Shift select all of those, and we're just going to call the new folder hardware. All right, so I guess that was the reason for the size is they're doing Philister for the location for. So that's going to be a machine screw. Wow, that looks really tight. So let's go with the 1/4-20. I have to double check the head size. I'm not going to hurt my feelings to use the Phillips as opposed to the flat. And that one was called out as a 5/8. Now we'll go ahead and accept, locate. and locate, and locate. All right. So interesting, let's see, we put that at 406. This is actually shown at 414, so would want to grab one of those screws and actually measure the head before it went in production on the pieces. All right, so drill rod, drill or dowel pins. Yeah, the 440s. So those should be kind of interesting. Let's see if it'll pick up that at least one of those. But chances are I'm going to have to change it. And this was pulled out as a machine screw. So we're going to call it since we have the Phillips and the slots, there is no matching. All right, so when you end up with this kind of elliptical shape, well, it dropped one in. It found something. All right, so it must have found most of the cylinder. And we're going to go 1/4 inch. Rotate over, set it for position. And as far as its depth, then we're going to set it for tangency. All right, and then this one should pull out a little bit and set for tangency. Save. All right, so the other ones are the pins. All right,